number 3, a cube of base side 40 mm rests on the ground on its base with all the vertical faces equally inclined to picture plane. One vertical edge is touching the picture plane and is 20 mm to the left of the station point, which is 75 mm above the ground and 50 mm in front of the picture plane. Draw the perspective view of the cube. We just draw the reference line. This is the starting point. We call it as picture plane PP. Now we draw the top view of the cube with one vertical edge touching the picture plane. At the same time, all the vertical faces equally inclined to picture plane. All the vertical faces equally inclined to picture plane. So therefore, we draw a square in the top view with 45 degree inclination on either side. This is 145 degree line. Again, we can have another 45 degree line. The square, because it is a cube, we have both length, breadth and height, all are equal, and it is given as 40 mm. 40 both sides. So that we can locate the arc. So this can be drawn. Yes. So we take the naming as P, Q, R, S, then 1. P, Q, R, S are the points at the top, and 1, 2, 3 and 4 are the points at the bottom respectively. So here is a square, the top view of the cube, touching the picture plane with one vertical edge with all its vertical faces equally inclined to the picture, 45 degree on either side. We have the base side 40 mm, and hence this distance, it is 40 mm. So this distance is 40 mm. Now it's given that the one vertical edge is touching the picture plane and it is 20 mm to the left of the station point of this vertical edge, and it is at a distance of 20 mm. So we take 20 mm, and we draw a line. We call it as central plane CP. So this is where the station point lies, and the station point is given as 75 mm above the ground and 50 mm in front of the picture plane. So we take 50 mm from the picture plane, 1 2 3 4 5, and name this as S, small s, that is the top view of the station point. We give an arbitrary gap of 20 mm. This in front of distance is 50 mm. This in front of distance is 50 mm. And we locate S dash. S dash is given as 75 mm above the ground plane. Therefore 1 2 3 4 5 6 7 7.5 75. We take 75 mm above the ground plane. So this S dash is located 75 mm above the ground plane. So we have 75 mm here. So we take S dash 75 mm. So and we mark this line as ground line GL. So central plane lies 20 mm to the right of the vertical edge which is touching the picture plane. In other words, the vertical edge which is touching the picture plane is 20 mm to the left of the station point. So then after locating the ground plane, we can project the top view of the cube to find corresponding front view. So here is again 40 mm. Right. So we get the front view of the cube. We name the points on the top as PQRS. Accordingly, we have P dash here, Q dash, then R dash here, and S dash here. We have 1 dash, 2 dash, 3 dash, and 4 dash. Now we connect all the front view points with the front view station point with the help of rays. So first point we can join with the ray, then the points of P dash and R dash can be joined with the help of rays. Again Q dash can also be joined. Similarly, we can join 2 dash, with the help of rays. 1 dash 3 dash can be joined with S dash the help of rays. 4 dash can also be joined with S dash. So thereby all the front view points are connected with the front view station point. Similarly, we can join top view points with their corresponding top view station point. So here is top view station point and top view point, first ray, then you have second ray, again for 3 and R we have third ray, for 4 and S we have fourth ray, so this can be joined. After joining this, we understand this P ray intersect the picture plane here, so we bring it down, it meets the P ray here, so we are able to get capital P. Similarly, one touches here and the corresponding one ray comes here, we are able to get P1. Here we have to note down P1 with a true 40 mm height. This is 40 mm, height of the cube is 40 mm. Just because the vertical edge is touching the picture plane, we are able to get the same true length in the perspective view also. So it is obvious we get 40 mm because the cube has got length, breadth and height all 40. So we need not have to mention this. Anyway, to just understand capital P1 as 40, we mention 40 here. Similarly, we go to Q. Q intersects the PP at here, so we get a point called Q1, so that it touches the Q ray and the ray 2. When it touches the Q ray, we get capital Q, and when it touches the ray 2, we get capital 2. The perspective point for perspective projection 2. Similarly, we can find out R1 and 3.1. So we project this so that it touches the R1 and 3.1 rays. 3.1 makes point 3 and R1 makes point capital R. Again, this can be followed for S1 also. So S1 is projected, there is a line through S1, so that at same time it should touch the ray 4 also. So we have ray 4, perspective 4, and ray S gives you capital S, that is the position of point S in the perspective view. So we join P and Q. So join P and Q, join P and Q, P and Q, then Q and R, Q and R, Q and R, R and S, once again we join P and S. We get PQRS fully visible because the height of the observer is 75 and the height of the object is 40, and hence we are able to get the full view of PQRS. When we see the outer side, this 1,4 is visible. At the same time, S4 is also visible. P1 is also visible. When we view from here, 4 is the extreme point and 2 is the extreme point. So these 2 points are visible. Then we get Q2 also a visible edge, whereas points like 2, 3, joining 2, 3 may not be visible, so we make use of dotted line to join 2 and 3. Similarly, 3 and 4 is not visible, so we join with the help of dotted line. We join 3, 4 with the help of dotted line. Again 3R is also not visible, so we join once again 3R with the help of a dotted line. We have to make this top view dark. This is a dark line in the final answer. Top view PQRS. At the same time, PQRS is drawn in such a way that the vertical edge is making 45-degree with picture plane on either side. So we have a T square with a 45-degree on either side, and from this vertical edge which is touching the picture plane, we take 20 mm to the right side and we draw the central plane. The station point is 50 mm in front of the picture plane, so therefore we get the top view of the picture plane. We give an arbitrary gap of 20 mm. Then we understand that the station point is located 75 mm above the ground. So with this 20 mm gap we mark S dash and we take 75. We locate this ground line. From here we understand the height of the cube, that is 40 mm. Then by projecting all this we get the front view of the cube. We mark P dash, Q dash, R dash, S dash at the top, 1 dash, 2 dash, 3 dash, 4 dash at the bottom. Afterwards we make use of rays to join point S dash with station point S dash, point R dash with station point S dash, point P dash with station point S dash, point Q dash with station point S dash, point 2 dash with station point S dash, points 1 dash, 3 dash with station point S dash, point 4 dash with station point S dash. Similarly, we join all the top view points with the top view station point SP1P, S2QS, then S3RS, then S and the point S, station point S, then the point 4. Now we understand the intersection of this ray at the picture plane gives the location for the perspective point. So this at this location we project this to touch the P ray and 1 ray, we are able to get P1. Similarly, when we come to Q, we locate this at the Q ray capital Q and 2 ray at capital 2. Similarly, for point R, S and R intersect at R1 in the picture plane. We project this. So the intersection at the R ray gives capital R, intersection at the 3 ray gives capital 3. Similarly, the intersection of this station point S and the point S with the picture plane is small s1. When we bring it down, the S ray intersect at capital S, 4 ray intersect at capital 4. Finally, we join PQRS. It is fully visible. The reason is that the height of the object is 40 and the height of the observer is 75. So we are able to completely view this top portion. Then we take the outer edges and make all the visible edges dark and the invisible edges dotted. So this portion gives you the final perspective view of the cube.